now, and then we'll go. Right, can you read the first question to me?
Oh, what? Just refresh again.
What's the first question? Lynn, have you got it?
A metal rod
Yeah.
of length 1.05 meters
1.05 meters.
is moving at a velocity of 25.5 meters per second.
This I know this one. And then what's the induced current?
Magnitude of the EMF.
Yeah.
But they only said the uniform magnetic flux of density 2.6
Yeah, so the B is, what's it, 2 point...
6 times 10 to the power negative 2.
Yeah, because it's probably being dropped in the Earth's magnetic field.
Yeah.
So the formula here is BLV.
Yes.
Right, so multiply those three numbers.
0.696 should be.
0.696 volts. All right. Hey, question done. Right, what's the next one? Who's done number 2? You've done that? Who else has done it? Good? Okay. Did you do number 3? No, you said you did 2. Did you do number 3, Gina?
Yeah.
And did you do number 4? Okay, so how many questions are there altogether?
8.
Okay, so how about I do question 1, 2, 3, and then we take turns doing the rest. So read number 2 to me, please, Dorian.
A coil of wire is rotated in a clockwise direction.
Oh yeah, okay, so it's something like this, yeah. Oh no, and this is inside of it.
Yeah.
And it's being rotated that way.
Yeah.
And this is north and this is south. Okay. Is it going to be what?
In a clockwise direction,
Yeah.
at a constant angular speed in the uniform magnetic field as shown in the diagram below. A. Starting with the coil in the position as shown in the diagram.
Which is like this. Yeah.
Draw a graph to show how the EMF induced in the coil varies with time over 2 cycles.
No, it's
No,
the
it's a
cost
cost
one.
graph.
The sine one is when it starts vertically.
Yeah. So 2 cycles.
Okay.
Yes. B.
Okay.
The coil is connected to an external load. In which direction would a conventional current flow when the coil is in the position is shown in the diagram?
Right hand rule. Let me see. Force is up. Current is flowing in here. The current is going in here and out here.
Yes.
Yes.
It looks like this in the picture. Current in, current out.
Oh, so you have to write it like.
If they give you a way to describe it using letters, is the diagram labelled?
Oh yeah.
So let's see the picture of the label. So
A,
the
B,
current.
C, D.
Yeah, so the current flows from A to D.
Oh, okay.
Right, what's next?
Question 3.
Oh.
Can do that.
Oh, come on, guys, these are easy. Why didn't you do them? They were too easy for you. You geniuses only do the hard questions, is it? Right, what's number 3?
Question 3a. State Faraday's law of electromagnetic induction.
Okay, so Faraday said the EMF is equal to minus n delta phi over delta t, basically.
B. A circular coil has 300 turns of thin copper wire with an average diameter of 6 centimeters.
Okay. 300 turns? 300?
turns.
Yeah.
Yes.
Yeah, okay.
The coil is placed in a magnetic field of flux density 0.025 Tesla,
Okay,
which passes along the axis of the coil.
yeah.
1. What is the value of the flux linkage for the coil?
Okay, so the total flux linkage is NBA, which is 300 times 0.025 times pi times R, which is 0.03 squared. So what the heck is that?
0.
0.021.
Oh yeah.
2.
What did you do wrong, Dorian?
Radius.
Oh, Dorian. Okay, what's part 2 then?
If the
What
coil is turned through, yeah,
Oh, it's now it's at an angle just.
yeah,
So 0.0212 and what's the angle?
it says turn through 180 degrees. It says, thus reversing the flux linkage
Ah, okay. So what do they ask for?
in the time of 2 milliseconds.
Ah, okay. They want the EMF.
Yes,
So that is 300 and how many milliseconds?
2 milliseconds.
2 milliseconds. And it will be basically 0.025 minus 0.025
Oh,
because it gets flipped around.
yeah. Okay. Like
Yeah.
the last question.
Yeah, we did an example of that in class, didn't we?
Yeah.
No.
Yeah.
7,500 volts.
Ah, no.
Wait, what?
Can't be that big, can it?
0.
Is it that big?
0.
Well, it does turn quite quickly. 2 milliseconds is quick.
It was 300 coils.
And it's 300 coils. So what did you get?
7,500.
It's that high, really. 7,500 volts. Now,
That's in the Earth's
Yeah.
magnetic field. Well, how do you get something?
it's the time.
You can't.
2 milliseconds is like a centrifuge or something, you
That
know?
would generate a lot of energy. Yeah.
Okay.
Yeah, that's remarkably high. 2 milliseconds.
It's 200ths of a second. No, 2,000ths of a second.
Yeah. Wow, okay. Well, that's what it is. Okay. And is there another part?
No, that's it.
Okay, so are we on to number 4?
4, 5, 6, 7, 8,
Okay, nobody's done number 4, right? So,
why do I feel like 7 and 8 look the same?
are they copies?
They seem to be. No, slightly different.
Okay, I'll give you a couple of minutes before I do number 4. Let's see if you can get it. What's weird in number 4? What type of problem is it? A coil or
It's kind of weird.
It's a coil.
another coil? Okay.
It just like suddenly reversed in direction.
Radius,
And what happens to the coil?
Suddenly reversed in direction.
Ah, you've seen this twice now.
Mm-hmm.
Finished it, Zach?
Flux passing through the coil versus flux linkage in the coil.
Flux linkage always means a total. So my guess would be the difference between the two
Just type
is
it.
the N.
Okay.
Flux is B times area, right?
Yeah,
Well,
yeah.
And that's in Webers.
yeah.
Okay.
So it's just pi r squared
Yeah.
times 0.25 times 10 to the minus 3. And then linkage is just times 0. And that is just that over 1.5, let's say.
Zach, you're South African, aren't you?
Yeah.
There's a restaurant, there's a program in Griffith College, a hospitality program. So every year they do, they open up a restaurant for to train the staff. And like, you know, if you're doing hospitality, they'll make you be a waiter or a chef or whatever, you
Yeah.
know. But they try to run it like, they do it in one of the classrooms, but they run it like a proper restaurant, you know, they put the tablecloths out and all this stuff. And anybody can book, and it's cheap because they're not trying to make money, they're just trying to practice being a restaurant. But this week, it's South African food.
Really?
So if you, I think you can book on Griffith's Facebook page, like if you search, I can't remember what it's called, like training restaurant or something. You could, if you contact them, you could, you know, go tomorrow or something. Every week they change the menu. So this week is South African. So I thought, oh, I'll say that to Zach now. He can judge how accurate they
Did you
are.
have a look at the menu?
No, I didn't look at it yet. Just someone was telling me that they are open this week, and they're doing South African this week. So I thought, oh, when I was looking at it there, I was just thinking, oh, actually, yeah, I better let Zach know. So, do you think he'll go, or?
Maybe.
Yeah. Yeah, but you can look at the menu anyways.
The South Africans just have fries, which
You
are
can see-
barbecues around the rest of the world.
You can see what the menu's like. You can see what it's like. All right, do you guys have number 4 done yet?
Yeah.
Yeah. Okay, great. Zach, can you read number 4? What you got going on in it?
Circular coil wire having 55 turns of average radius 1.5 centimeters has a magnetic field of flux density 0.25 millitesla passing through it along its axis. What is the flux passing through the coil?
BA 0.25 times 10 to the minus 3 times pi times 0.015 over 2 squared, isn't it? What's that?
0.015 over 2?
Oh, sorry, it's already radius, isn't it?
Yeah.
I was thinking of the last question.
1.77 times 10 to the minus 7.
1.77.
You wrote it again. It is
No.
the radius.
Yeah. I keep dividing it by 2. Yeah, sorry. Right. What is it?
1.77 times 10 to the minus 7.
Okay, and is the next one the linkage then?
Yeah. So that's just 55.
What's that? 85, 90.
9.71. 10 to the minus 6. Micro
Yeah.
Teslas?
Webers.
Micro Webers.
Okay, next.
If the magnetic field was suddenly reversed in a direction on a time of 1.5 milliseconds.
.25 millitesla, isn't it?
Yeah.
Be minus minus is plus, and also the milli I can take it out and cancel it with that. So I end up getting 55 times 1/3 basically. So what's that? 3, 2, 7, 14, what's it about? 16 volts?
18.3. 3.
Is that it for that one?
Yeah.
Easy peasy?
Yeah.
I think so. Right, what's next? 5, is it?
Yeah.
Okay.
State Lenz's law of electromagnetic induction.
Yeah. It's the induced current always travels to oppose. No, hang on, let me get my grammar right. The induced current travels in opposition to the change in magnetic field. Something along those lines, doesn't it? Actually, I'd be interested to see what they put in the marking scheme for it. Try it for a couple of minutes before I do it.
Bring your own phone. Found it already. What? I don't know if it's in.
Just want to see the phone like it's causing sound.
Which one? The one. Cost. The link. It's Kobe Bryant's.
Okay.
Rest in peace.
There was something suspicious about his pilot as well, like the pilot got sanctioned before
Yeah,
for
but that was in 2015 or something like that. Ages ago.
2015 is hardly ages ago.
Well,
Do you know? Anyways, it
flying now.
doesn't matter now.
Yeah, he did the same. He flew in bad weather.
Yeah.
No.
Can you change radians on the fly on this car? Oh, you can. Did you get that?
What? Which one?
5.11.
5.
What did you get? Huh?
0.113.
No, wait. Then I did something.
What's number 5 about? Is it another coil?
Flux linkage and
It's, yeah. No, it's not a coil. It's a
What
wire.
It is a coil.
What was your code today?
NBA cos theta.
Yeah.
You in the right mode?
Yeah.
Oh,
You in the
You're
You're
in the
right.
I'm not in the right one.
Oh, Dorian. Classic Dorian.
No, that's not.
No, you're right, that's not classic Dorian. That's classic Diego, it is. You know it's true, Diego. It's classic
Because
Diego.
I was gonna say it, so.
I pulled a Diego today.
You pulled the Diego today. That is right. Let's make that a phrase there. We need to use it enough.
Yeah, okay.
Okay.
Yeah.
You done?
Yes.
Right, is 5 short or long? What's happening? Short one, okay. Will we have a look at it? Oh, do you have the marking scheme, Zach? What does it say for
Oh, yeah.
Lenz's law? Yeah.
Let me check.
Lynn, did you get number 5? Yeah, good, okay.
Which version is it on?
Sorry, what?
What version is it? What's...
It's, wait, 0506 semester 2 version 3,
You
8,
sure?
7.
I thought I saw 14, 15.
No.
14, 15 semester 2 version.
Oh yeah, sorry, that was the last one. Yes, 14, 15
Okay.
semester 2.
I'm
version
curious
4.
what they say for what they give for Lenz's law.
But that was the one for, oh yeah, sorry. Version 4, A5.
Well, while he's opening that door in, can you read the info to me? What we got?
The direction of the induced EMF is such as to oppose the flux change causing.
Yeah. Oh, I said change in magnetic field. I should have been a bit more precise. Should have said the change in the flux. Yeah, yeah. Okay. What's the info there, Dorian, for this?
Question 5.
Yeah. What's the
A
info?
rectangular coil of wire is free to rotate.
Oh, it's another one of these jobs.
Yeah,
Yes,
and it's exactly the
It's
same.
exactly the same.
same.
Okay, so yeah. Okay, so is there any part that's different?
Yeah.
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 Magnetic field is 0.25 Tesla.
0.25 Tesla.
First determine the direction, but that's the same
Yeah.
as the last question. Second one is determine the total flux linked with the coil when the normal to the plane of the coil makes an angle of 25 degrees with the magnetic field direction.
Coil has two.
They want the total flux linkage.
Yeah. Coil has 250 turns and its cross-sectional area is 2 times 10 to the minus 3.
Yes.
Oh, is that all?
Yeah, in mid-air close 25.
Oh, and it's at an angle of 25, huh?
Yeah.
So that's easy peasy. What did you get for that, Zach?
0.113 Webers.
Oh yeah, that's 0.113 Webers, okay. And what's next now?
Done.
That's it.
That's it?
Yeah.
Ah,
But for the
fine.
next one,
So number 6 looks hard?
no, it's not hard. It's just.
Well, give it a go there. Let's see. Oh, is it being dropped?
Yeah, but I need to know how many seconds.
With its axis parallel to the
It's
ground.
19.81.
Yeah, so they just say it's dropped like that.
Why don't they just say horizontal?
No,
With
because
its
they want
axis
it.
parallel to the ground. Are they trying to confuse people?
They wanna
Yeah,
be
that
fancy.
was.
Nice.
But it did say pointing in the east-west direction anyway. They said pointing in the east-west direction, so it has to be like this.
It doesn't have to.
It's pointing in the
It
east-west
says
direction.
pointing in the east-west direction, yeah.
Where's IBET college?
And it has multiple axes.
That's why, anyways, this
Which axes are they referring to?
The English
That's
axis.
true, that's true.
the English axis.
Dorian, don't be so harsh to poor Zach now. I get what you're saying. I would have perhaps they could have said rod lying horizontally.
So this is MGH equals.
Is
They
it?
don't have
Yes.
mass.
Yes, MGH.
There's no mass.
What are they asking
You
for
don't,
first?
you don't need the mass.
Determine the velocity of the rod just before it hits the ground.
Yeah.
Oh
See
yeah,
that.
yeah. Come on, guys, wake up.
Which one? B squared equals U squared plus 2AS.
Huh?
Yeah.
Yeah.
Yes.
You don't need
Yeah, or you could use energy
yes.
too.
MGH
Yeah.
also have them.
Either, both work.
MGH.
Yes, they
You don't
work.
have the mass.
It doesn't matter, Zachary. The M's cancel.
Oh. GH equals half U squared.
Yeah,
Mm.
yeah.
Oh, now you have this. Equals to-
Yeah, it's the first example I did, isn't it? Yeah.
Did you get small volts?
How much?
did you get? I got a really small one.
Yeah. 3.5.
Well, yeah, it should be, because remember the example.
No.
No, it should be really small, because remember the example I did with the metal rod
Yeah.
in the Earth's magnetic field?
Yeah.
Millivolts, right?
1.8 times 10 to the minus 5 times 19.8 meters per second.
It should be like of the scale millivolts.
Why did you times it by? Shouldn't it be 1.8 times 10 to the negative 5 times area over time?
Yeah, no, that works too, Dorian, but you have to be very careful about what you say the area is.
The area isn't it
Just do
20?
BLV.
Yeah, no, hang on, now, just to be clear. This question is a little bit unusual because as the rod drops, it accelerates.
Yeah.
So, the formula I gave of BLV, they would accept that in the exam. But technically speaking, that is not accurate because that formula assumed a constant V, which we don't have.
The V at the
Is the V at the end, is it?
Before
Just before impact. Fine, okay, fine, that's fine then. So it should be okay. So if you're using the area, if you're using the other formula, then you have to think about carefully what the area is at the moment of impact. So what area is it, at what rate is it sweeping out area at the moment of impact?
20 meters. 20
Is it
meters.
falling at 20 meters per second?
90.8.
Ah, okay.
Yeah, what's the V at impact?
90.8.
And what's the length of the rod?
1
20.
meter.
Oh, length of the rod, yes, 1.
So that means 19.8? That means 19.8 meters squared is the area being swept out at impact. That's the delta A per delta T.
Sorry, what was the area?
Yeah, 19.6 times 1.
Square, yeah.
Yeah, so Dorian, if you recall, if you can see with my pen,
Yeah.
the area is the area being swept out. Do you understand what I mean by saying swept out?
Okay.
Yeah, this is why it's kind of easier to use the BLV formula.
And where did you get the time from anyway?
V equals U.
For what?
18.
Well,
You don't get to say.
when we do the question, let's go read it, Zach. What is it?
A rod of length 1 meter pointing in east-west direction is dropped from a height of 20 meters with its axis parallel to the ground. Determine the velocity of the rod just before it hits the ground.
Okay, I think I will go with mgh equals a half mv squared.
So V
M's cancel, v equals root 2gh, which equals root 40g. Yeah, which is what?
19.8 meters per second.
Okay, what's the next part?
Horizontal component of the Earth's magnetic field is 1.8 times 10 to the minus 5 Tesla.
Okay,
Determine the EMF developed across the ends of the conductor just before it hits the ground. 3.57 times 10 to the minus 4.
millivolts.
Well, 35 millivolts then. It's 10 to the minus 4
Ah, yes, of course, thank you. 35.7
millivolts.
millivolts. Yeah. No, Dorian, do you want, if you were using your formula here, just so everyone can see, Faraday's law of induction, the n here is 1, I don't care about the minus, delta phi over delta t. What's changing here? It's not the b, it's the a, so it's b delta a over delta t. So that's b times delta a over delta t, to be clear. And what's happening is, there's the ground. When the rod hits the ground, it's going at a speed of 19.8 meters per second. And this length here is 1 meter. So it means at the moment of impact, it's trying to produce an area of 19.8 meters squared per second. These are per seconds. So that is 19.8. This whole thing here is 19.8. So it'll be, you can realise it's the same thing as what I just did a moment ago, 19.8 times the B.
What happened to the delta T?
But the delta T is 1, because this is a per second.
That's good.
Yeah, I used to do these questions this way, and then I saw that they used the formula BLV in the formula book, they added it into the formula book, and the marking schemes kind of have it being done this way, so I stopped doing these questions using Faraday's and instead used the BLV formula. Sorry, what do you need something up on the screen in particular? Or? Yeah. Yeah. What's the story with 7? What type is 7?
Kind of looks like circuits questions.
Really?
Yes, only the last
For the
part has to
circuit
do with
shown
AC.
opposite, calculate the combined resistance.
Oh, can I see it?
The total current. the
Is it only really the
potential
last part that's making it appear?
Yes.
Ah, okay. Okay, that's why I put it in there. Can you just
Well,
do...
not really. If the cell were replaced by a sinusoidal AC supply of 12
Yep.
volts
Oh,
Yep.
okay.
Yeah,
RMS,
yeah.
what would be the peak?
Just to be
current?
clear, okay, so guys, can you just do the last part in 7 and 8? Now, just to be clear, let me write it down. RMS, I didn't actually tell you what RMS stands for.
But how do you...
Guys, RMS. Do you remember I gave you the formula V average equals V max
Yeah.
over root 2? And it was not V max over 2. Do you remember I said that? Yeah. So this guy is called the mean average. Have you done this word in maths?
Yeah.
Yeah. But this one, you don't call it the mean average because it's different. Guess what you call it? You call it the root mean average. What does the S stand for?
Standard.
Root mean. Root mean. No, don't look. I'll look. Anyways,
Cross
even,
the fingers.
no, my phone is slow.
Whose fault is that?
Yeah.
Root means square.
Oh, of course, because root is just short for square root. Yeah, root means square. Mean square root. You know, root means square. Square root mean. Mean square root. Mean root square. Whatever.
Would make more sense if it was the square root.
It would, wouldn't it? It really would.
So 12.
Maybe they were French or something. I don't know.
They speak baguette.
Yeah.
6 root 2.
But
Yeah.
does it matter where it is? Because it mentions like the 50 ohm resistor. Like
Well, read out part 7. What's it say?
Of course it matters.
No, hold on. Come on. Read it out to me. Dorian, you read 7 to me, please. The last part, just.
if the cell was replaced by a sinusoidal
Yeah.
AC supply of 12 volts RMS, what would be the peak current in the 15 ohm resistor?
So,
Which is-
using the formula, 12
6
would
root 2.
equal V max over root 2.
Mhm.
So V max equals 12 root 2.
6 root
Huh? I thought I said it was. I thought I said that it was 12 the average.
Oh,
Yeah.
V. Oh, yeah. My bad.
I put 12.
Now, what do they want? They want the current, don't they?
Yeah.
So if I use my VIR triangle, the I equals V. Oh, come on!
I
No,
thought
so
it was
it's
talking about something
the-
else.
What's the
The
resistance?
resistor is in parallel
Yeah.
with 2 different other resistors.
Yeah.
Yeah,
They
but
have
what
to
they
do-
want the peak current in which resistor?
15?
The 51.
And do we know the voltage is the same as the supply if they're in parallel? We do, don't we? Parallel resistors have the same voltage, don't they? Don't they?
Yeah.
Is the voltage 12 root 2? Look at let me see the circuit diagram.
Yeah, it is tall.
It's
Oh, no, it's complicated because there's another resistor in series
Yeah,
there, the
that's what
2.5, yeah. So we can't.
voltage is not
yeah.
12 root 2.
Anyways, I don't care about that. That's an electricity question. I just care about that you got the B max.
Okay.
So what is the B max? 12 root 2, what's that? 16 point, so rounded it'd be 17.0 volts.
Yeah.
Okay, try it again with number 8. Give me the max voltage.
It's the same question.
Same numbers?
Yes.
12 as well?
Yes.
Alright, okay. So it's 17.0 then. Was that the last question?
Yeah.
Yeah. Now guys, I don't mind doing questions like this with you, but you realise this eats into our window of revision time at the end of the year.
Yeah.
So I'm indifferent. What I mean is, if you prefer to go slower to do these in class and have less revision time, I'm happy with that. If you prefer to go faster and have more revision time, I'm also happy with that. I'll let the class dictate the pace. Wait, is that a mistake or? It's a mistake. I shouldn't do this.
Dorian's the chancellor of this fascist state. So
Is she? Is she the class rep?
yeah.
Yeah. Okay.
Unfortunately.
So she makes
Yeah.
the
Well, how about you
decisions.
become faster?
She's the boss.
Hang on, Dorian. Unless you want a dystopian future now. I see him more as a Trump figure. You know? Yeah.
Cool.
Yeah. He's charismatic. Everyone likes him. He's a little bit racist. He's a Trump figure.
Do you like walls?
Yeah, do you like walls? That's yeah. That's it, yeah. No, seriously though, are we feeling? Will we pick the pace back up, or what are we thinking? What? I suppose my question is, what was the problem with the homework? Have you got a lot going on?
Yeah.
What's happening this week with you?
We were doing applications. And,
All right. You have to write personal statements.
Yeah, and well,
Oh,
I did. I don't know.
And what else is going on this week?
And we have a chemistry
me
lab
and
report.
actually basically I just doing lab report and the English coursework.
English.
Right.
How to read the test.
Your time is taken up with all this nonsense.
Yeah.
Yeah. When's the applications are finished?
No.
Only
Just
for-
beginning. We'll see how we get on next week then. Yeah. Yeah. No, we have class tomorrow.
Yes.
Yeah. Okay. Well, we continue with Transformers tomorrow. Question? Yes.
For question 4.
Yeah. Wait, just before you go, hang on, just to check, make sure 4 is okay.
Max King and White, I don't know why it says wrong.
What answer did I get for 4? Did I do 4?
Yeah.
What is it?
Let me just check. Gina thinks the American scheme's
No.
American scheme's different, maybe. 4,
Oh, it's 18.
18.3. That's not what this is. Wait, am I looking at the right one? 1 point. Okay, that's right. Correct. That's right. Correct.
5 over 3. It's 18.3 recurrent.
There's
Oh,
the area.
5 over 1.5. Yeah.
where is the area? Hang on, what is this? The area is missing, isn't it? Isn't it?
Yeah.
Yeah, I left out the area here. Thank you for spotting that, Gina. So I should have had, what is the area here? Yeah, I should have had 0.015 squared pi. Can someone take that and multiply it by that?
0.012.
Are you sure?
0.013.
Yeah.
0.0.
It's
That's
not-
wrong still.
But
Huh?
the Max King, it didn't add the 0.25. It didn't add. So I think it's wrong.
They made a mistake and I made a mistake. Both our answers are wrong. That's fantastic. But we think the right answer is this now.
Yeah.
0.013 times.
Times
No, it's 0.013.
Oh, just 0.013 volts. And what did they do wrong with the mark scheme? They forgot. What do you think?
It didn't add that to.
Do you think they reversed the directions?
Yeah,
They didn't really flip it. They just reversed the direction.
didn't add that. I don't have the question.
The magnetic field was suddenly reversing direction.
Yeah, that makes, yeah. So it's 0.25, 0.25
Minus minus.
minus minus, yeah.
Yeah.
No, I mean.
Also, where's the 55? Oh, they're using the previous answer.
Yeah.
Yeah. Oh, you're right.
Because
Yeah, they left out the 0.25.
Yeah.
Yeah.
Oh,
So
okay.
Yeah, no, you're right. They left out the 0.25 and I left out the area.
So did you ponder our question yesterday?
What question was that? Thank you for checking that, Gina. What ID number was that one? I need to update the database with a note.
it's 376.
376.
What are we wondering about
Okay.
yesterday?
376. Okay.